Hi everyone, I'm Kevin from Docker. I work in the build team, and today it will be a presentation about CI continuous integration with our build tooling exclusively. By the end of the session, if I got some time, there will be a Q&A, so feel free to have your question prepared so we can move along. So the first things I want to talk about, obviously, it's the CI provider we are going to talk about today. It will be GitHub Actions. This is a popular provider we have, and we want to focus on this chapter, which will be just a short introductions on GitHub Actions. Their main components there are, obviously, it will be, of course, about the Docker Actions we are providing, and today we have 6 of them in the marketplace. And to get started, a basic workflow we can start to work with. This is a basic step so you can understand how we can evolve from this basic workflow, and how, of course, to optimize using build cache as well. And as you know, there is multi-platform support with Docker images, and this is a popular trend nowadays. And so you will see how we can create optimized container images for different architectures. And following this chapter, there will be something linked to publish your materials or to publish your image using automating tags and labels. This is also using our official actions. Following this, there will be how we can unleash and simplify your workflow using Bake. This is also a build tool. Not really popular, but I want to focus a bit on this one in this presentation so you can see the advantage of using a new definition to do your builds. And then there will be another talk, another small part, but really important, I think, because we see many bad patterns being used today on CIs, and secrets are an important pattern and deserve its own chapter, I guess. And finally, we'll see how we can use container-based workflows and achieve a greater portability from your inner loop and also on CI. So let's get started with GitHub Actions. What is a GitHub Actions? So you have first, of course, the workflow itself. So this is where your pipeline is defined with events, runners, jobs, and steps. I will not expand on this specification, but just so you have a better understanding how it works, because I will show many workflows during this talk. So you have also an event. So this is a specific activity on the repository that triggers the workflow run. And there are many of them, like push, pull request, workflow dispatch is one that is commonly used to manually trigger your workflow. There is also the runner, so this is the server that runs your workflows, like Ubuntu latest, macOS latest, and what GitHub purpose, also self-hosted runners if you have one. And each runner can run a single job at a time. There is the job. This is the set of steps inside your workflow that is executed, of course, inside the same runner, so inside the same instance. And the action, this is, I would say, a custom application you can build. It can be a container, it can be a JavaScript action, it can be also a composite action. So this is running some shell command, something like that. But for the purpose of this presentation, it will be about all Docker actions we are provided. So there is 6 of them. So let's see what is the current state of our actions today. So we want to ease your pipeline. And to do this, we provide these GitHub Actions to have a seamless integration in the workflow. The most popular of this one is probably the build push action. This one is basically to build and push your image. It's using our build tooling. So this is BuildX and BuildKit with full support, like multi-platform builds, using secrets, exporting your cache. You can use also different builders, deployment and spacing options, thanks to BuildKit. And we are going to talk, of course, about the other action there. So they are more I would say satellite actions. Like, for example, you need the login action to be able to push your image. So you need first to trigger the login action, and then you can use the build push action. There is, as you can see, the action toolkit. It's not an action on its own. It's just a library we are using for all of our actions. It provides some utilities on command logic around our build tooling. It is a minimal wrapper, if you want, that can be used. And it's an easier API for us to interact with them. And this toolkit, of course, is consumed by all our actions today. So let's see a basic workflow. So to get started, do you see something in the back, or it's fine? Yeah. Okay. Nice. So this workflow will be triggered on the workflow dispatch event. A workflow dispatch event, like I said before, it's just manually invoke. Like you can just go to your repository. You can trigger this workflow manually without any specific event. And this will use two of our official actions. There is the login action, and there is the build push action. So the login action will log in there on Docker Hub. And after that, we can use the build push action to tag your image and push your image. So this is really simple. And of course, I use a simple Go project because I want to talk about multi-platform later. So it will be easier for me to have a project like this. This is just a simple web server. There's nothing fancy behind it. So let's run this build. I would have liked to do a live demo about this to see this in action, actually. But it will be screenshot for this presentation. So as you can see there, it took approximately 24 seconds. That's not bad to build something. But we can do way better if we're using leveraging cache, actually. So if we see the build logs there, we can see this stage is never cached. It will run every time you run this workflow. This stage will run, and there is no instruction being cached. So we can leverage caching thanks to this. So we can do better before optimizing our workflow with cache. We can see first what BuildKit offers in terms of caching implementation to export your cache. So there are many backends available today in BuildKit. As you know, maybe BuildKit, when you do a build, automatically caches the build result in its own internal cache. But as GitHub runners are ephemeral, this cache is not existent, is not persisted. So the idea with BuildKit, it's also support to exporting the build cache to an external location, making it possible to import it in future builds, so between runs. And we have the following cache backends available, but we also have this one that we are going to use today. This is the GHA one, GitHub Action one, that is using the GitHub API. It's basically the same as the official GitHub cache action. This is using the same kind of API. To enable this cache in your workflow, you just need to add the setup buildX action. So this setup buildX action, it will create a container builder to leverage all the BuildKit features available today. So it's using the latest table of BuildKit that are currently not available with BuildKit embedded inside the Docker engine. So now we can set the cache from cache to instructions to say, oh, okay, I want to use this cache. I will push this cache to exporting this cache on GHA, and also so I can also read this cache from GitHub Action backend. So if we build now this cache saves both, of course, the cache metadata and layers to the GitHub cache service. It is an Azure Blob storage under the hood with, on top, they have their own API. And this is the same backend being used by the official GitHub Actions, of course. So if we build this project, let's see how it performs with the new options. So as you can see, it takes 8 seconds after cache being set, so this is way better. And we almost save, yes, 67% of the build time, so this is pretty great. if we look at the logs, so we can see now that are the instructions from the build stage that are being cached. So yeah, with the GitHub cache backend with GitHub Actions, it's the easiest remote cache you can use today when you're using this CI. If you are using another CI provider, let's say Cycle CI or whatever, you can use, for example, an S3 backend or AZ Blob backend, an Azure Blob Storage backend if you want to. But you need the authentication layer, you need things like this. With GitHub Action, you have this available right away. You don't need anything else. Before going further, there is something you need to be aware of with the cache in GitHub Actions. So the cache has a size limit of 10 gigabytes that is shared across your repository. So GitHub will save your cache, but will begin evicting caches if you exceed the size. So recycling the cache too often can result, of course, in runtimes and in slower runtimes overall. So you need to be careful about this. What you need to export, by default, it will just export the last stage of your Docker file. But if you want to export everything, like for example with the mod max, you need to be careful about this. There is the scope key. So the scope key by default is named build kit. So this is the key that is where your cache will belongs to. And it can be useful, for example, if you have a mono repo with many projects inside it. So you can say, oh, okay, for example, this cache, I want to put this cache in foo and the other cache in bar. So it cannot be shared together. And you can restrict to, with a mono repo to multiple projects. By default, build kit today doesn't export cache mounts in the GitHub Action cache. So if you wish to do this, today we have a workaround using these GitHub Actions. So you can export also your cache mounts. So now let's talk a bit about multi-platform build. As you know, Docker images support multi-platforms, which means a single image can contain multiple variants on multiple platforms on OS. And this is a popular trend, specifically on CI. So this is something we want to show today. So to do a multi-platform build, basically you just need to provide a single input. I said, in this case, I just want x86 and an ARM build. And to do this, you just need to specify this. And also, in some cases, it depends a lot how your Docker file is written. So you also need to install emulators. And you also, for this, you can use the setup QEMU action we provide that will just install the emulators for your build. So if we run this build, as we can see, yeah, it's 3 minutes, yeah. That's not good. That's a lot just to build for an extra platform. So do you have an idea why? Someone has an idea? Why it takes so much time? No? Maybe? Okay. I have an idea myself. So maybe the logs will give us an hint. Let's take a look. So yeah, I think we found the culprit. So as you can see, the ARM1 takes almost 3 minutes just to build this project, as the other one takes 30 seconds. So yeah, this is the issue. So yes, the emulation is guilty there. So basically, as you may know, in the GitHub infrastructure, the Ubuntu latest runner is on x86 architecture. So when we do the ARM build, it will just use emulation. And emulation is a huge penalty when you do a build. So that's why it takes so much time. So how can we solve this? There is 2 solutions to solve this issue. And what we are going to see is how to use cross-compilation in our Docker file to remove this penalty using emulation. So let's get back first in our Docker file. So as we can see, as we have seen in the logs, the build stage will be built against their respective platforms. And in this case, using cross-compilation with Go can be quite easy. So we just need to pass a set of variables so we can use the target architecture. So we provide arguments in the global scope of your Docker file. So when in the front end, when you use this set of arguments, you have the specific target being used. And in our case, using cross compilation, we want to use the native platform to do the build and use the target arguments to do the cross compilation with the Go compiler. But how to infer this? So for that, we can use the -- platform in your Docker file, so it will be strict to the build platform. This is the one where your build runs. And we can specify then the target OS and the target architecture. And just after that, we can specify also the Go OS and Go Arch, so it will match the target platform you defined. So now for our build, sorry, it's a bit small, but the workflows start to be getting bigger, so hopefully you see something. So I just need to see how much time it takes. So now it's 47 seconds. It's better that's 3 minutes. That's because, yes, we are using cross compilation. So if we go to the logs now, we can see the AMD64 and ARM64 takes the same time. There is still some penalty there. If you recall before, it took approximately 24 seconds. It's taking 31 seconds because there are 2 builds occurring on the same runner. So there is 2 builds on the same instance. And what we could do, for example, is distribute this build across multiple runners, so there is less penalty, and you can merge the result together later. But we are going to see that later. So keep in mind, of course, that cross-compilation might not be suitable depending on the programming language. For example, with Go, it's really simple. With Rust or so, it can be simple as well. But if you can't do this, the only viable solution you can use is having a native node on ARM, another native node on AMD, for example, AMD64, and you can build on each of them, but it requires a more advanced setup in your workflow. So yeah, there is some constraint with this. Now that we have seen how to do multi-platform build, we can see how we can manage our image tags and label when we push our image. So it can be a bit complicated in CI. We see that often. We see that at the beginning of the GitHub Actions. You can have big chunks of scripts just to specify the list of tags you want to push, depending if there is a similar tag being pushed on your repository, or if you use, for example, Edge releases, you merge something on main, and you'd say, oh, okay, I want to be the name of my branch being pushed. So you need extra conditions with this. So this is a bit of pain. So to save you the trouble, we have developed a GitHub action that lets you automate the creation of tags and labels in your workflow. So let's take a look. So I just need to define an extract step before building using the metadata action. So only the image input is required. In this case, it's a repo. It's a simple repository I use. You can use many images if you want. If you want to push to GHCR, Docker Hub, at the same time, you can define both. If you want to, there will be deduplicated tags. And it will generate the tags and label that need to be applied after that to the build push action. So in this case, I just set the tags with the input from the previous step. For example, when I push to the main branch, it will generate this list of tags. So there is only one that is called main. And there is also a list of OCI image format specification labels that are automatically generated. We don't have a way to opt out for this kind of thing. But for example, as you can see, there is the description one. This is taken from the GitHub API. So this is the description of your repository. You also have the title of your repository that is being taken and put there. So you can track what is in your image using this kind of action. This is pretty useful. I think GitHub using, when you see the README, for example, of your image in container images, it takes advantage of the OCI labels and display more meaningful information in your README, for example. And if I push a v1 tag there, v100, it generates latest and v100 as well. So it can be a bit cryptic, so let me explain what's going on under the hood. So with this kind of customizing tag, you might wonder how the action does it. So by default, if you don't specify the tag's input, it will be the default values will be tip schedule and ref with event branch, tag, or PR. So the tip schedule will be used when there is a schedule event only in your workflow, and will tag the name. The tag will be named nightly by default. And the ref under the Git reference, like the branch, the tag, or the pull request as well. And there is more rules under the hood for specific use cases. For example, a common pattern in a Git flow is to release your project by pushing a sender tag. And in our case, you might not just want to have the image tag and also the latest being set, but maybe you want something like major minor, and you also want just major, and you want commit SHA being set. So to do this, you need to specify the rules you want to apply to your tags. And in this case, for example, I say, okay, I want the full version, but I also want major minor being set because some users like to don't care about patches and will use only the major minor in their image. So in this I handle the sender tag, and what it will produce in this case, for example, when I push v100, it will say, okay, I have 100, I have 10, and latest, and SHA with the commit SHA being set. So this is automatically generated for you. You don't need to care about it. It will set this for you. And for a pull request, for example, it will generate, for this case, PR 196. And same for the SHA that is being set every time you push something. So this is pretty useful. We have also other cases. There are, for example, there are specific ones for Python versioning. There is also other ones that are being used for edge cases, like you want to put some flavor, like under a prefix, suffix. If you are, let's say, I want an Alpine version of my image or a Debian version, you can prefix with Debian or something like that. So there's many rules under the hood. And the documentation will help you. We have a huge documentation in the repository if I want to take a look. Now that we have talked about this, I want to talk about Bake. So, as you can see, the workflow was pretty huge, and I want to drastically reduce the size of this workflow. So Bake will help us with this. So before getting started, you might not know what is Bake. So I will go back to the roots, so with the build command. So as you know, you can have something like this with the build command today. It's quite huge. There are many flags available with the build command, and what you can do, we want to simplify this kind of thing because porting this thing from your local environment to CI, another CI, maybe you need to copy paste stuff, you need to maintain both, so that's not great. So in your workflow, you will have something like this maybe, because you need to port your local command to inputs inside the push action, so that's quite huge. It's not ideal. We need to maintain both. I don't like it as well. You need to update the contributing notes, documentation to build our project. So yeah, that's not great. So with Bake, we can do something like this instead. So you just need to define, for example, the push flag. This push flag will just say, okay, I want to build stuff, to build something, and I want to push it. So before going further, I want to first talk to you about what is a Bake definition. So this is the starting point for using Bake. So with Bake, we want to let users define projects, specific reusable build flows that can be easily invoked by anyone using a definition file. So this definition file can be an HCL file, can be a JSON one, or a compose file as well. You can specify multiple files, and they will be merged together in the specific order, of course. And it defaults to the following ones. if you don't specify anything. So it looked like compose itself. It looked at the default files available in where you execute the bake command. As you see, I put a small art next to HTL because, yeah, that's why I'm going to talk about in this talk. HTL is very powerful for this kind of thing. So the HTL format supports variable block definition. Like, as you know, Terraform, it's the same thing. It's almost the same thing. You can use variables as build arguments for your Docker file or interpolate them in attributes values in your bake file as well. And there is also a set of general purpose functions you can use, any functions that are available by GoCTY, but also you can use your own user-defined functions. So let's see an example of a HTL definition. So this is how it looks. So this is basically, it has supports for custom build rules, as you can see. It's allowing better code reuse across your project with different target groups. A target, so you can see, for example, there is image and image all. It reflects a single Docker build invocation with the same option that we would specify for Docker build command. And a group, as you see up there, the one called default, it can specify its list of targets with target option. A target can inherit build options as well by setting the inherits options to the list of targets. So, for example, the image all inherits from the image one. So you can inherit from the options of the image. And this is really similar to Terraform and to how we provide a way to define variables. So the HTL file format also supports variable block definition, like this one with tag. And they can be used to define variables with values provided by the current environment as well. So if you use an environment variable, it will replace this value by the environment variable. And now I want, for example, to build the image all target. I just need to define image all docker build bake image all, and that's it. It will build exactly what I want. So this is quite nice to streamline the inner loop and to other environments like CI environments. So let's take a look now with a simple one. So the previous one was a huge one, so you can see approximately how the reference is done. So now let's get back to the basic workflow we had at the beginning and add the bake definition. And in our workflow, we just need to use now just the bake action. So we have also an action with bake, and this one doesn't handle tags at all. It just uses push, and it will use by default the image name that you see up there, crazymax DockerCon, and it will set as tag this image. So now that we have seen this, as you can see, we have also the canonical representation that is shown inside the action, so you see what's going on and what's taken into account, like variables that are being passed. So you can see it inside the build push, the bake action, sorry. So it's using the --print tag to show the canonical representation. So I wanted to talk about bake because now with secrets, I still want to talk about bake, or we can use it also with using bake. So we see too many often bad practices around CI, and we see people using build arguments to pass sensitive information, credentials. So that's not good. Sometimes it can be inside the image itself. It's just not at build time. So using secrets at build time is what you should use in such case. The secrets is a simple way to use it. So before going further, I want to add a new stage in my Docker file to test my project. And I will do as well add a new target inside my bake definition. And right before this, I want also, before build and push, I want to test this project. But there is an issue. I know my test is using require access to the GitHub API. Otherwise, it will be skipped. So I need to pass somehow the GitHub token to this workflow. So how can I do this? So I can add a build time secret for this. And basically, this is, in my big definition, I just define a secret I want to expose. So I want to expose the secret name GH token using the environment variable named GitHub token. And this is the same as using the secret flag also with the build command. And there is nothing different. And now in my Dockerfile, I can move these secrets when I run my test. And also, I can use this environment variables GitHub token that will be used inside my test as well. And finally, in my workflow, I set the GitHub token envar with the GitHub token secrets provided. So it will be passed through, and then it can be used inside my container directly. So this is pretty useful. This is secure because it will only be used in this run instruction. It will not be in your final image when you want to push this image. It will just be used for this stage only. So now, with that in mind, we can explore the vast potential of using containers in your CI. So how to achieve greater portability between the inner loop and your CI environments. So the idea, yes, is to use the most if you can using containers because you achieve better portability with this. And if I add, for example, a new target, I will call this one lint. So my backfiles start to be huge, but this is useful. I can reuse this one if I want in the future. And create a lint stage as well in my Dockerfile. And that will just run golang CI lint to check if my code is OK. And in my definition, in my workflow, I will now add a new lint step. And if we take a look at the logs now, we can see my lint stage pass. It's OK. But there is something strange. Yeah, we see there is something called it exports an image, but I don't want that. I just want to run the lint part. But by default, the build command will write the image to the local store every time you do a build. But you can build without exporting anything. So to do this, you can use you can avoid for this target only to use the cache only output type. This output type discards basically outputting the build result, but still writes the cache for this specific target. And I should do the same as well for the test one. I forgot to do it before. So test, I don't output anything. Let's say in the future you want to export the test definition to post it to codecov or something like that. You could export the build result as well. So this is useful if you don't want to waste time or if your stage doesn't need to output anything but run tests. So as you can see, we have a common pattern. Every time we add something, we add a new step in your workflow. So your workflow stack to be quite huge. And in this case, we need a new step every time. And here, for example, I can group test and lint because the purpose of this step is to validate my code. And what I can do now, is remove or merge two of them and just have a validate one. And I can call validate. So there is more abstraction around your local environment, so you can tell to users, oh, just run validate. It will do everything for you. You don't need to run. You need to tell, I run test, run lint, run anything else. So you just validate, and that's it. And of course, it will run in parallel, thanks to BuildKit. So there is no sequential like makefile. When you use a makefile, this is sequential. But in this case, it will run in parallel. And as you can see also in the canonical representation, we can see it will call both ones. Sorry if you can't see yet, that's a bit small. Another chapter, I have some time? Yeah, okay, I can talk about it. So I didn't want to jump to this section for this talk, but I think that could be interesting. So previously, for the test and lint part, I said it runs in parallel on the same runner. So this is useful, but if you want, for example, if you know, for example, that a test can take, it can be a resource constraint, it takes too much CPUs or RAM, and you want to split this between runners to take advantage of GitHub workflows. So to solve this, you can distribute the group of targets that we have. So we have the validate one, but we want to distribute this across runners. So not part of the same job, but of two jobs, actually. And to solve this, we can distribute group targets on multiple runners while keeping the same bake group. So the local flow is still the same. It will just change a bit inside your workflow. So there is a pattern with GitHub Actions to set a matrix dynamically. So that's a bit cryptic. We want to ease this in the future using the bake action. So you will not need to do this, and we could create automatically invoke multiple runners. So what it does in this case, this prepared job, as you can see, I use the buildxbake command with the validate group. It will print the list of targets that are available for this group, put it inside a specific target output for this prepared job. And after that, I can use a matrix with the target values. So it will be the list of targets that are available, which are test and lint. So it will run the validates both times on each runner. So test on one runner and lint on another runner. So a better representation of this will be before we had a single validate one that runs both test and lint in parallel, but now they are split between runners. So it takes less time, 43 seconds instead of 57 seconds, because they run each one run on its own runner. So this is a way to distribute builds, and we have examples in our documentation to distribute the builds as well for multi-platform images. So you can have, let's say, 5 platforms you want to distribute across 5 runners, because doing this on the same runner can be quite resource intensive, and you want to split this around. And also another use case, people don't know much. Many people build something to push an image on a registry. This is something many people do, but you also want maybe to output the binary and maybe push this binary to GitHub release or something like this. So you can achieve this with BuildKit. So you just need to change the output and say, oh, okay, I want to output not on a registry, but I want to output my thing locally in my client. So in this case, it will output the binary from the stage called binary to the local folder bin. So if we create now, I will create a dedicated workflow for this. This workflow will be triggered when a tag is pushed. Yes, when the tag is pushed, and after that, when this binary is done, I will create a GitHub release and push this binary. And you can do this, for example, for other use cases, like you have multiple platforms. You can do the same in this case. So you can use do a multi-platform build, extract all the binaries, and push them inside GitHub releases directly. So you just have to use a final action, but even this action, we could put this inside the Docker file itself, but it requires more work because you need to talk to the GitHub API. So this is something easier to use a GitHub action already available. So what we have seen today, so we have seen how to use cache exporters and also how to create efficient images using different architecture. Pipeline strategy for automating tags and label. Bake, we talk a lot about Bake to simplify the workflow and reduce the overhead in your CI. Using build secret as well with Bake, and also how to use containers only to achieve better portability between your local environment and your CI environment. Before closing in, we have some projects using container-based advantage, like, for example, we have BuildX, of course, using this kind of pattern. It can do many things across compilation, updating vendor, checking vendor, There is also Golang CI lint and many things we can do. XXSO is a great example because it's using a new pattern using matrix. So there is also matrix inside Bake. I didn't talk about it at this presentation, but we have great documentation about this. So what GitHub Actions achieve today, you can achieve the same inside Bake itself. So this is something useful. And we are doing this inside this project. So that's it. And thank you. If you have any question, feel free to do so.